Hello, this is Miss Poor, and this is a lesson 502 ellipses recording. Um, Here are the objectives for this lesson. After you read the lesson, which I strongly encourage, you should be able to define ellipse mathematically, write the equation of an ellipse, and identify real-life applications of concepts of conic sections. Here are the vocabulary words for this lesson, and I encourage you to not just breeze through them, but go through, maybe download your student guide. We'll have all of these, but you need to know these as we go through the lesson and for your quizzes and tests. I always pull that wrong one down. This is an ellipse, focus of an ellipse. Let's pull the wrong one again. Focus of an ellipse, the major axis, the minor axis. And like I said, as we go through the lesson, we'll talk more about each one of those definitions. And oh, I'll go back right quick. I would suggest that if you're taking notes, that you go ahead and pause and fill these in and then come back to the recording. Here are just some examples of an ellipse in the real world. My favorite is the watermelon. And we've also got our solar system. And this right here is a room in the White House, I believe. Oh, nope, it's the Statuary Hall in the U.S. Capitol building. And then, of course, down here, this is the White House, and this is the backyard of the White House. And of course, Batman. I love me Batman. All right, let's go to the next screen. This is a recording that you can go watch. I don't think you'll be able to click it here through YouTube, but I will send it along with the video recording. Or you can just type in that address and it'll take you right to it. All right, first let's go through here and look at an ellipse equation. Here's what your equation is going to look like. And this particular equation, your center is going to be at the origin. Your foci is at negative C. You'll see that right here, negative C0, C, and then you have a positive C0. And then your vertices will be at negative A and 0 and positive A and 0. They're always going to be directly opposite of each other. And whenever you see this, you can tell that it's a horizontal ellipse, and your major axis will be the x-axis. Now, for the vertical, this is going to be your vertical ellipse, and you can see right here, everything is the same pretty much, except that now your y-axis is the major axis, the x is the minor. The next thing you want to notice, and we'll talk about this several times throughout this lesson, is that you'll have x squared over a squared for your horizontal. It'll be x squared over b squared for your vertical. For some reason or other, my little go to the next slide button's not working. Okay, so on this one, let me get to these notes. If you think of an ellipse as a squash circle, the eccentricity of the ellipse gives a measure of just how squashed it is. This formula will produce a number in the range of 0 to 1. And notice we're just taking the C value and dividing it by our A value in our formula. So if the eccentricity is 0, it's not squashed at all, and it just looks like a circle. If it is 1, it is completely squashed and looks like a line. So a degenerate ellipse is a special case of an ellipse. Oh, I guess it'd help if I took away the box here. There's your formula for a degenerate circle. And a degenerate ellipse is a special case of an ellipse. Its graph is a point, which is actually the center. And as we go through the course, we'll always refer to the degenerate circle as a point. Here is just a table that I put together for you to use in your notes. This is everything you need to know about a vertical, an ellipse, and then you're going to notice here that you've got b squared in the denominator, and over here for horizontal, you got a squared in the denominator. And notice that your vertices and your foci also change. These in the middle are just ways to determine the values of each of those. And later on, we're going to be working with this formula right here, but it's not going to look like this. We're going to be subtracting c from both sides. So that's how we're going to determine what the value of b is. Okay, so for finding the equation of an ellipse, and then so we can graph it. So let's not look at the graph for just a second. Let me put a square over that. We're not going to look at that for a minute. The first thing you want to do is it says find the equation of an ellipse with the center at the origin and one focus at 3, 0 and a vertex at negative 4, 0 and then graph the equation. So first, what we're going to do is we're going to find the center that, and we're going to determine the major axis and then determine if it's a horizontal or vertical ellipse. So if you look, the ellipse has its center at the origin, and since the given focus and the vertex lie on the x-axis, and the way that we know that by looking, because negative 4 is an x and 3 is an x, and then our origin is also 0, 0, which also puts it on the x-axis. So since everything's on the x-axis, that's going to make the ellipse horizontal. Hold on, I said vertical, I was looking for my pen. So the major axis is the x-axis, making it horizontal. All right, next, let's look at the distance from the center to one foci, which is your C value, okay? So this, you don't need the graph to do this. You know that the distance from the center is 0, 0, and they gave us the one foci is 3, 0, which I've just re-put down here. So we know that distance, and remember your distance is always positive. So it's going to be 3. My C value is going to be 3. Now let's find the A value. That's going to be the distance to the center from one of the vertices. Well, they gave us the vertices of negative 4, 0. And so remember, your distance is always positive. So going from the origin to negative 4 is going to be 4 units, 4 positive units. So I know my A value is 4. So now, in order to write my equation, I have to find out what my B value is. So all I did here was I just rewrote, I want to know what B is. That's why I rewrote that formula, subtracting C from both sides, because I'm solving for B. So if you look right here, and I left out some steps, and I'm going to include them here. Let me get my toolbar out of the way. Okay, so if I say B squared equals A squared minus C squared, that's going to give me, my A value is right here. It's 4. My C value is 3. So B squared is going to equal 16 minus 9. So, and you don't have to square it. 16 minus 9 is 7. And so that's what B is going to equal. So you can see the steps that I did to get that equation to find out what my B value is. So, and remember, let's go back and look at my chart. I said right here that if you've got a horizontal, that A value is going to be your first denominator. Okay? If it's horizontal, you're going to choose your A value. So that means that's where I get my equation of my ellipse. I'm going to take that A value, and when we square it, it's 16. So there we go. Then this is my C value, which is, I mean, my B value, I'm sorry, my B value, which is 7, and it's already squared, and you can see that. Now then, now let's look at the graph and how it all falls into place. So we've got our origin is the center. They gave this focus at 3, 0. Well, we know the second one is going to be the opposite, which is negative 3, 0. And then we know that our vertex is negative 4, 0. And you can see that right here. And then my exact opposite is going to be the positive 4, 0. Now, to find out what your vertices are on your minor axis, you're going to take that B value. Your X is going to be 0 because your origin, your center is the origin. So we know X is 0 in both of these. Then we're going to take the square root of 7, and then that's going to determine our vertices of our minor axis, and then you'd be able to connect the points. Your foci, remember, will not be used to connect the points. But now let's put it in a calculator and see what it looks like. The first thing, they said set the, well, here's my formula, I mean, my equation from, we just did that. Now I want to see what it looks like in the calculator. Well, you're going to have to set your viewing window so you'll be able to see the whole ellipse in the viewing window. And it says here that set the viewing rectangle using a square screen that includes the intercepts. And it just says perhaps you could use these. I always set my viewing window just a little bigger than what it needs to be. Okay, so for my x's, I said it went from negative 6 to 6, and for my y's, I went from negative 5 to 5. But also look here, I can't enter this into my calculator in this form. All right, remember it has to be in y equals in order for me to get it into the calculator. So the first thing I'm going to do is subtract x squared divided by 16 from each side of the equation. And so this is what I end up with. Now, if you'll remember, you want to get rid of the denominator. That 7, we need to get rid of it. So in order to do that, we multiply both sides of the equation by 7. And that's what we end up with. Now, one more step before we can get this entered into our calculator, I have to get rid of that exponent, the y squared. So I'm going to take the square root of both sides. And that's what I end up with. Now, what's important for entering this in your calculator, don't forget the plus and minus. All right? So, let's see what our and says. So now graph the two functions. So this is what it's going to look like when I graph the two functions. I'm going to have to put values in y1 and in y2. So when I break down that plus or minus, this is going to be my plus equation. This is going to be my negative equation. All right? So the first thing I'm going to do is I'm going to enter in, I've entered in the positive equation right here. And you see the little arrow, that's just showing how I entered in the whole thing. Now, to enter in the negative equation in y2, I'm just going to go right here and say I want to enter in the negative value of what's in y1. So I just put negative, and if I remember right, I guess I could open up my calculator and see, and yes, it's not going to let me do that. Let me minimize all this stuff and get to my calculator so I can tell you the correct. I'm pretty sure you go to Y vars. Yeah, you go to Y vars on your calculator. Let me put this up here. Oh, it won't let me take a screenshot. Here, I'm just going to put this over on the screen. You go to, let me do this again. You go to this vars button. Then you're going to arrow over to Y vars. Then you're going to click 1 for function, or you can hit enter. And then you're going to hit 1. So let me show you how to do this. Let's just say I'm going to put a random equation up here. It's not going to be like ours because that would take too long to enter in. But let's just say x plus 2. Now I want to go down here. I want to enter in the negative value of x plus 2. So now I go to vars, arrow over to y vars, because what we're asking for is the y variables. I hit 1, and then I'm going to hit 1 again for y1, and then enter. Now see what my graph looks like. And if you want to see which one is which, that one right there, you see the cursor is on y1 equals x plus 2. If I go down, I see it says y2 equals the negative value of y and 1. All right, so let me get my calculator out of the picture. So that's how I entered this right here. And then I see the graph. Now, if I went and did a trace on this, um, this would show me my positive, and this would be my negative. And you notice they don't exactly touch at the x-axis, and that's just because it's a calculator. They are touching. All right, so let's look at analyzing the equation of an ellipse. Here's the equation. And when it says to analyze the equation, they're telling you to find the center, the major axis, the foci, the vertices, all of it, and then graph it. So let's hide our graph for just a minute. When I was teaching this in class, I had the graphs hidden, but when I go to record, my graphs aren't hidden anymore. Yay. Okay, so the first thing we're going to do is determine if it's horizontal or vertical. So if you look here, it says the equation is in the form of the horizontal equation where a squared equals 25 and b squared equals 9. Okay, because that a is larger, so I got a squared equals 25, b squared equals 9. So that's going to help me. Well, that's telling me it's horizontal. Now, to get the center, uh, my center is 0, and I know that because I got x squared and y squared up here all by itself. Remember when we were talking about a circle, we said when we see x squared, that's x minus 0 in the parentheses squared. Okay, so that's how I know my center is 0. And my major axis is along the x-axis. All right, so my next thing is I've got to determine what my vertices are. Your vertices, and this is where you go back to the chart that I showed you. Your vertices are at plus or minus a0, which is going to be plus or minus 50, because what you do is you get the square root of a. A squared equals 25. I get the square root of it. That leaves me with 5. Let me go back here right quick. All right, so remember when we say we're finding the vertices, we've got our h value, which is the center. You got h and k for your center. Well, h is 0, and then plus or minus a. All right, so that's where we're getting that. So let me go back. And remember, it said you got your K value. Well, my K value is 0. H and K are 0 because we're at the origin. And remember, my A value is I took the square root of 25. And notice that's a plus and a minus. All right, so now I want to solve. I know what B is. I think I just confused myself because I think I wrote this up wrong. But I still needed to find, um, I needed to find my C value, but I plugged that in for 16. I don't know why I did that because my B value is 9. Let's rewrite that so it won't be so confusing. Okay, I went back and I just covered up that so it wouldn't be confusing. I know that my B squared is 9. I get that from right here. I know my A squared is 25. I get that from right here. And I've got to find C squared. So all I got to do is subtract that 9 from both sides. I get that C squared is 16. I get the square root of both of those, and I find out that C equals 4. All right, so now I know, and right here it was correct. It's just that equation for figuring it out was wrong. And I got the B squared plus C squared equals A squared from that summary chart of vertical and horizontal ellipses. So the foci is your plus or minus C and your K value. So you're going to have plus or minus 4 and 0. So now let's see what all that looks like as a graph. Now that you've figured all of that out, we know just from the last step down here that our foci are negative 4, 0 and 4, 0. We know that our A values are the negative 5 and the positive 5 right here. And then when we get the square root of 9, we know that our vertices on our y-axis are 3 and negative 3. And so that gives us all the points we need to graph it. And also we know the origin is 0. So the big point here when you're analyzing the equation means you're going to find the center, the major axis, the foci, and the vertices. And in order to graph it, you have to go ahead and find out what the vertices of that y-axis are. All right, let's go to the next one. Oh, this is, I want you to pause for just a minute and see if you can tell me what are the coordinates of the vertices of the given ellipse. Okay, I'm hoping you paused it and we checked that out. Let's see um, what our feedback is and see what the correct answer is. Well, our correct answer is going to be C. I'll just put a little box around that. Now then, what we want to remember is that the vertices are where the ellipsis makes the sharpest turns. These should occur on the major axis. So first take the square root of 81 and we go 9 units to the left and the right of the origin on the x-axis to find the vertices. So that's where negative 9, 0 and positive 9, 0 came from. And I think next we have another multiple choice. So hopefully you pause it, see if you can figure this out. What are the coordinates of the foci of the ellipse in this equation? All right, now let's look. There again, you're going to be getting the square root of 16 and 25. And remember, I bet this one, let's make sure that A is going to be your correct value. And B says if you chose B, you didn't take the square root of the difference. And C says remember to find the foci. You will need to take the square root of the difference in the denominators. And then remember that to find the foci for D, you will need to take the square root of the difference in the denominators. So what we did here get my, find my pen. There it is. Okay, so say I got b squared equals a squared minus c squared. And now you go to your summary in order to figure out which one is B and which one is A. This one's going to be vertical because remember, your A always has to be the greater value. A always has to be greater. It said it like this, that A is greater than B, which is greater than 0. And since A is our greatest and it's under y squared, I know this is my B value. So b squared is 16, a squared is 25 minus c squared. Now I just want to get that 25 over to the other side. So I get 9, negative 9, equals negative c squared. Well, we can just get rid of that negative sign, multiply everything by negative 1. And so c squared, I take the square root of both sides, that gives me plus or minus 3. But remember, that's your trick right here. This is going to be your b value because your a value is always the greatest denominator. All right, here's another one, finding the equation of an ellipse, and then we're going to graph it. So I hit the graph right quick. You could have paused it and looked at it if you want. I just think it's more fun if we go through the equation and then compare to the graph. So find the equation of the ellipse having one focus at 0, 2, and a vertices at 0, negative 3, and 0, positive 3, and then graph the equation. So we're going to look at the focus and the vertices, determine what the major axis is, which will tell us if it's horizontal or vertical. So the given focus and vertices, I don't know how I wrote that sentence out like that. It doesn't make sense. But notice that all those points are on the y-axis, which makes it vertical. So notice you've got your focus is going to be at positive 2 and negative 2 on the y-axis, and your vertices are at negative 3 and positive 3 on the y-axis. So that right there tells you, hey, the major axis is the y-axis, and this means it's going to be a vertical ellipse. Now then, because the vertices are at 0, negative 3, and 0, 3, the center of the ellipse is at the midpoint between negative 3 and 3, which tells us it's going to be at the origin. Okay? So now I want to look at the distance from the center, 0, 0, to the given focus, 0, 2, is c equals 2. And the distance from the center to one of the vertices is going to be 3 units. So I know my C and A value. Now I've got to solve for B. And let's hope this equation's set up right. I don't want to have to pause again and fix it. Oh, it's perfect. So I've got my A value, which was 3. You go ahead and square it. I just flipped the equation. And then my C value was 2. I plug that in and square it. It gives me a 4. 9 minus 4 gives me 5. So that means my B squared value is 5. So that's going to give me the equation of the ellipse. All right, remember, since it's vertical, my A value is always greater than B, which is greater than 0. All right, since my A value right here is 9, my B value is 5. So that means that 5 is going to go under the x squared, and my A value 9 is going to go under the y squared, and that whole thing equals 1, always. So now let's look at the graph. And all we do is just plot all those points. And last, to get that minor axis right here, you're just going to say the negative and positive values of the square root of 5. and then just plot those points. All right, so now let's analyze this equation. Right now, we're thinking, that doesn't look like an ellipse equation because we're going to have to put it in the standard form. So to put it in the proper form, first we're going to divide each side by 9. And this is why we want that x squared value all by itself. So we're going to divide everything by 9. And plus we want this value over here to be a 1. Remember, I just said before, that always needs to be a 1. So anyway, this is what it looks like after we divide everything by 9. So that means that first denominator is going to be 1. It's x squared over 1. So that right there tells me, even if I don't look at the graph over here, that right there tells me I'm dealing with a vertical ellipse because my a value is always greater than my b value. And I kind of probably jumped ahead of myself. I put down here that the larger denominator is 9 and is in the y squared term. So based on the vertical equation, this is the equation of ellipse with the center at the origin and a major axis along the y-axis. So what is a squared, b squared, and c squared? This is a squared. 9 is my a squared. My b squared is 1. And I want to find out what c squared is. So I'm going to say a squared minus b squared is going to give me c squared. So that's going to be 9 minus 1 gives me 8. So remember your vertices, and you can look at that summary of ellipses that I gave you, that if you're looking at the vertical, your vertices are always going to be h and then k plus or minus a. Well, my h in this situation is the origin, so it's going to be 0. Then my plus or minus a, I'm going ahead and getting that square root of a to find out it's a plus or minus 3. That summary chart will also help you with the foci, which is going to be your k plus or minus c. So my k value is 0, so I'm not really worried about it, but my c value is 8. Well, if you simplify it and you get the square root of 8, you're going to end up with plus or minus 2 multiplied by root 2. And then my x-intercepts, that's going to be your b values with your x values. So my b value is 1, so I'm going to get plus or minus 1 with 0. And then this one didn't tell us to graph it, that's why I just left the graph up here. But you can see with all those points plotted out and how you can tell then that, yep, it's a vertical ellipse. Okay, so pause just a minute, look at this, and decide if it's true or false. The major axis of the ellipse from this equation is vertical. Okay, hopefully you pause for just a minute. So I'm going to look here. I've got a squared. Well, I'm not going to say a squared. I know that 81 is greater than 49. So there again, you've got to remember what we said at the very beginning. A is always greater than B is greater than 0. So 81 is greater than 49. So that tells me my major axis is going to be the x-axis, which makes it horizontal. So let's see if I answered that correctly. Yep, false. The major axis is horizontal since the bigger number underneath the x. All right, here you pause just again. What are the coordinates of the vertices of the given ellipse? And remember, your vertices are your origin and then your k plus or minus A, your A value. Okay, before I do the answer feedback, let's look at this. There again, A is greater than B is greater than 0, so that means my A value is 64. Actually, that's my A squared value. My vertices are going to be my K value. Well, I already know that the origin is the center. So there's my H and K value, H and K. So my vertices is going to be H and then K plus or minus A, not A squared, but my A squared equals 64. If I get the square root of both sides, I get 8. So my H value is 0, my K value is 0, plus or minus my A value is 8. So I'm going to get 0, 8, and 0, negative 8. Oops, my negative sign. There we go. So although I did them backwards, but it's still going to be the answer is A. I didn't, I don't, I think I put boxes around everything else. Oh wait, no it's not. Ah, I did that backwards, sorry. It's D. So remember that the vertices are where the ellipse makes the sharpest turns, and these are going to occur on the major axis. I'm sorry, I had it right the first time. It is that. I was looking at the vertical thing. That's my bad. I was looking at the vertical summary instead of the horizontal summary. I knew it was horizontal because this is my largest value. Okay? Every, this is correct. A squared, A equals 8. I'm sorry, my vertices should have been H plus or minus my A value and then my K value. So my H is 0, that was 8, and that's 0. Sorry, that doesn't look like a 0. So that gives me 8 and 0, negative 8 and 0. All right, sorry about that. I hope it didn't confuse you. Just remember, if the largest term is under the x squared value, it's going to be horizontal. So that means your major axis is going to be the x-axis. And that's how you go about finding the vertices. Now, uh, these next few slides are you're just going through and you're doing everything the same way, except the origin isn't going to be your center. And this is kind of a little cheat sheet for helping you find out what's what. Let me get to that in my notes. So let me go to this next slide. So here we're going to find, I'm just going to cover up the graph for just a minute. All right, so we're going to find the equation for the ellipse with the center at 2, negative 3, and one foci at 3, negative 3, and one vertex at 5, negative 3, and then we're going to graph the equation. So they've already given us the center, and so all I'm showing you right here is since we already know the center, we know that H is 2 and K is negative 3. Now on this one, we're going to see the focus, the vertices, the major axis, and is it horizontal or vertical. So the first thing you would do is plot the center, the focus, and the vertex, and note that the points all lie on the line y equals negative 3. Therefore, the major axis is parallel to the x-axis and makes it horizontal. Let's go ahead and look at this. This is just the step that you would take and going ahead and plotting it, is you would plot that center point, and then you're going to plot the focus because we're given the focus. One's at 3, negative 3, And we're given one of the vertex is at 5 and -3. So they went ahead and plotted that. There's your 5 and -3, and then your 3 and -3 are right here. And remember, when you're going to focus, I mean, when you're going to, I don't know why I keep saying focus. When you're going to graph, you're going to do the exact opposite. Okay? So you're going from your center, which is 2, to your x value, which is 5, and that's going to give you 3 units. So you're going to go 3 units the other way. And you're going to do the same for your second focus point. Oh, and that was where I was kind of getting ahead of myself. Let me get that little orange box off the bottom. Okay, so my next step is to determine the distance from the center to one foci. So my center is 2, -3. My focus is 3, -3. So that distance is just going to be 1. So that's how I know to go to the left 1 unit. This is what I was talking about a while ago, is going from the distance from the center, which is 2, -3, to the vertex, 5, -3, and that's 3 spaces. So I'm going to go 3 spaces to the left to plot that second vertex. So then we're going to go ahead. Do we need to solve for B? Yes. So here I just put in that a squared is 9, c squared is 1. I get the difference of those, and that gives me 8. So 8 is going to be my b value. So what I did right here was I just wrote down what the equation of any ellipse is. When your center, you got to include your centers here. We know that my h value is 2, k value is -3, a is +3, and b, we go ahead and get the square root of 8. So that way we can plot it. And they did that right here. But when I'm writing my equation, I've got my a value here. I've got my b value here. Notice how a is greater than b. That's how we knew it was horizontal. And then I go ahead and plug in my h and k values in the top. So that finishes off doing that equation. You remember that your center, I gotta find my pen. Oh, there we are. Your center, please ignore the squigglies, is h and k. Here's my h, and here's my k. My h is going to be a +3, and my k is going to be a -4. You always switch the signs of what you see. So you should have gotten D as your answer there, and let's see what their feedback says. All right, on this next one, how many units long is the major axis in the given ellipse? And hopefully you're going to pause and read through that. All right, let's just look at what answers we got here. A, this is the number of units from the center to the ellipse along the major x-axis. This is the square of the number of units from the center of the ellipse along the major x-axis. C is the square of the number of units from the center of the ellipse along the minor axis. And then D is the number of units from the center to the ellipse along the minor axis, and E is going to be your correct answer. All right, and that is going to be it for our ellipse lesson. And if you have any questions, just please let me know. I think I'm going to go to that slide right quick. Here's my contact information. Just remember that we have open office for tutoring 11 to 11:30 on Thursday and 1 to 2 Monday through Friday. So we'll see you then or in our next CC session. Thank you.